Before we start the selection sort, we need to check how to compare items in Java first. Java has primitive types and complex types. Primitive types include integer, double, boolean, and character. We're not going to compare boolean, so we are going to count only int, double, and char. And complex type is class type. So whenever you make a resource class, so it can be like a robot and string. We also did like a weight, distance last year. For the primitive type, when we compare two data, like when I have int x equals 5 and int y equals 7, I can compare x and y by using inequality operator. Even character, I can compare character x with a, then character y is b. I can also compare character x and y by using inequality, like something like this. So primitive type is storing the value directly into the variable space. So it is easy to compare. How about the complex type? Complex type is whenever I make an object. So Carol is now pointing the big box, big memory spaces, which has all the information about like its location, number of beepers. So when I have robot Carol, and robot Lisa, there is no way to compare by object. So in this case, we need to make it as a comparable type. That means we are supposed to implement comparable or comparator interface. Then by building the compare method, we will be able to compare two objects. That is happened in string class already. In the string class, string is already comparable. That means string class, the built-in string class in Java already implements comparable. So because of that reason, we can compare two strings by using compare to method. And by using this result, we can decide which object is bigger. We also made the weight class last year by making it as a comparable. So this is one sample here. If you want to make weight class to be comparable, you're going to implement a comparable interface by giving the generic type. Generic type means because a compare to method actually written for just a comparable. But there is a problem. If I just say comparable other, this other does not know any feature of the weight class. So actually, I cannot call other the pounds because other is comparable. Comparable do not know what is pounds, what is ounces. So because of this reason, we can put the generic type. That means this comparable is for weight class. So my comparable knows weight. So into the compare to method, instead of the comparable type, I can pass a weight type. Then it makes us to compare easily. This weight class is comparing pounds and ounces, so real weight, which one is heavier. So you can calculate the number of total ounces of the mine, the number of total ounces of the other weight. Then by just subtracting, you can get the result. So whenever I call compare to method with one weight to another weight, weight one that compared to, when I call it in my main method, for example, it will return positive integer, negative integer, or 0. If it's 0, that means they have exact same number of pounds and number of ounces. Then if they weight 1 is less than 0, that means weight 2, the other weight is bigger. It's heavier. Then also if weight 1 is, if it returns a positive integer, that means weight 1 has the larger number of ounces. So manually, we are going to decide how to compare two objects. There's another example we can think about. This is a member class. This member says last name, first name, member ID. And the programmer decided to sort this member object. It decided to compare only last name. So depends on the last name, they're going to sort it. Or we can compare by last name for two members. So in this case, in the compare to method, we are going to put only the last name feature. Last name is a string, and string already know compare to method, so we use a compare to method for comparing two string. Then it will return the string compare to method result. So this is another design we can use a comparable interface.